NASA has issued a warning. On March 14th, the moon will take on a deep red hue, and this time, something unusual could unfold. As Earth's shadow engulfs the moon, millions will witness a total lunar eclipse. No telescope required. Just your own eyes to take in the eerie spectacle. But here's where it gets interesting. While the moon transforms, something else might make an appearance in the sky, and you won't need any special equipment to spot it either. As long as you have a clear view of the sky, you're all set. Want a closer look? A pair of binoculars or a telescope will enhance the experience. The best part? No need to fight through crowds. This isn't a fleeting comet only a lucky few will catch. It's a grand celestial show visible to anyone in the Western Hemisphere who simply looks up. But what follows may leave you speechless. First, the penumbral eclipse begins. That's when the moon enters the outer part of Earth's shadow. Honestly, it's not much to look at, just a slight dimming that most people won't even notice. Next, things get interesting. The partial eclipse kicks in as the moon starts slipping into the darker part of the shadow, making it look like something is taking a bite out of it, slowly covering more and more. Then comes the main event, totality. This is when the moon is completely engulfed in Earth's shadow and turns that eerie burnt orange red. That color? It's basically every sunrise and sunset on Earth happening at once, reflected onto the moon. Talk about dramatic lighting. Once totality ends, the whole process plays in reverse, slowly revealing more of the moon as it moves out of the shadow until it's back to normal and the eclipse is officially over. But that's not all. As you gaze up at the sky, keep an eye out for a few special celestial guests. Jupiter and Mars will be visible in the western sky, shining brightly enough to catch your attention even without a telescope. Meanwhile, the moon will be making its way through the constellations Leo and Virgo, which will be easier to spot thanks to the reduced moonlight during totality. But the real excitement goes beyond just watching the sky. There's so much more to explore. Once you dive into the science and history behind it, the experience becomes even more fascinating. Lunar eclipses have fascinated humans for thousands of years. Ancient civilizations saw them as omens. Some thought they meant a king was about to fall, while others believed they were warnings from the gods. The Inca believed a jaguar was eating the moon and would come down to Earth to feast on people next, so they would shout and bang on drums to scare the beast away. Pretty dramatic, right? Meanwhile, in ancient China, they thought a celestial dragon was attacking the moon, so they made all kinds of noise to drive it off. Basically, a lot of yelling and banging things together. These stories showed just how spooky lunar eclipses seemed before people understood what was really happening. Believe it or not, the moon doesn't always take on the same shade of red during an eclipse. Sometimes it appears as a deep blood red, while other times it leans toward a rusty orange. This variation depends on factors like the amount of dust and pollution in Earth's atmosphere. If a major volcanic eruption has recently occurred, the moon may appear even darker and redder due to the extra particles lingering in the air. So if this eclipse looks especially eerie, you can credit Mother Nature for the dramatic effects. For centuries, people have looked up at the moon, marveling at its eerie glow and the way it seems to shift and change. But every now and then, it does something that makes even the most skeptical observer stop and stare. It darkens, then turns a deep, almost unnatural red. Some call it haunting. Some say it's a bad omen. NASA, on the other hand, calls it a lunar eclipse, and they're already sounding the alarm for a big one coming up on March 14th. Here's the simplified breakdown. A lunar eclipse happens when Earth moves between the sun and the moon, blocking sunlight and casting a shadow on the moon's surface. Unlike a solar eclipse, which is only visible from specific locations, a lunar eclipse can be seen by anyone on the night side of the Earth. If you're in the right place at the right time, you've got a front row seat. The moon turning red is fascinating, but its orbit holds an even bigger surprise. Instead of a perfect circle, the moon follows an elliptical path, meaning its speed and distance from Earth are always changing. On top of that, Earth itself moves around the sun in a slightly tilted orbit, making things even more complex. That's where NASA steps in, using Kepler's laws of planetary motion and Newton's laws of gravity. Yes, the apple falling guy, to precisely predict when and where these cosmic events will take place. These celestial events are predicted with incredible precision, thanks to data from space telescopes, lunar satellites, and powerful computers crunching numbers at mind-boggling speeds. Lunar eclipses don't occur every month, even though the moon completes a full lap around Earth roughly every 29 days. This is because the moon's orbit is tilted about 5 degrees compared to Earth's, causing it to miss Earth's shadow most of the time. However, every so often, the moon crosses a special spot in its orbit called a node, where everything aligns perfectly. That's when the magic happens. Not all lunar eclipses are the same. Some are partial, where only a portion of the moon enters Earth's shadow, while others are penumbral, meaning the moon passes through Earth's outer, lighter shadow, creating only a faint dimming. The real showstoppers, however, are total lunar eclipses, when the moon plunges completely into Earth's dark umbra, turning an unmistakable shade of red. But why red? The answer lies in Rayleigh scattering, the same phenomenon responsible for the fiery hues of sunrises and sunsets. As sunlight passes through Earth's atmosphere, shorter wavelengths like blue are scattered away, leaving behind the longer, redder wavelengths that filter through and illuminate the moon. The shade of red can vary depending on factors like pollution, volcanic activity, and weather, ranging from burnt orange to deep, almost blood-like crimson. NASA doesn't forecast eclipses just for the sake of it. Each one offers a valuable scientific opportunity. By observing how sunlight bends through Earth's atmosphere and reflects off the moon, researchers gain a fresh perspective on our planet's atmosphere. This same technique is also applied to studying exoplanets, helping astronomers determine the atmospheric compositions of distant worlds. Eclipses also act as natural test sites for space equipment. Scientists take advantage of these events to examine how instruments respond to sudden shifts in light exposure. Lunar probes and space telescopes collect data that help fine-tune sensors, enhancing future space missions. Since eclipse conditions resemble aspects of deep space travel, they provide an ideal opportunity to calibrate and improve tools for exploring the cosmos. Another major challenge? Communication. During a total lunar eclipse, Earth's ionosphere gets disrupted, interfering with radio signals. If future lunar bases depend on Earth for guidance, an eclipse cutting off communication could be a serious issue. Astronauts must have systems that function independently of mission control, allowing them to manage emergencies on their own, without contact, in the dark, and in freezing conditions. Energy storage is another critical concern. While batteries are essential, they have limits. The key challenge is ensuring future lunar explorers have enough stored power to endure extended eclipses. This requires developing ultra-efficient energy storage systems, already a tough task on Earth. The upside? Overcoming these challenges for space could drive breakthroughs in energy storage technology for use back on Earth. Some scientists suggest that lunar eclipses may influence the moon's thin exosphere in ways we don't yet fully understand. During an eclipse, interactions between charged solar particles and the moon's surface could lead to unexpected effects, potentially impacting dust movement and long-term surface changes. While the moon lacks an atmosphere like Earth's, it still responds to the sun's presence or absence in ways we are only beginning to explore. As more nations and private companies enter the space race, studying lunar eclipses becomes increasingly important. Any mission sending humans or machines to the moon must account for these events, as overlooking them could lead to equipment failures, mission setbacks, or worse. Each study of lunar eclipses brings us closer to making space exploration not just feasible, but sustainable. In the years ahead, as humans return to the moon, these eclipses will become part of everyday lunar operations. Challenges of living on the moon. Astronauts must adapt, engineers must innovate, and mission planners must anticipate every challenge. What was once a rare and mystical phenomenon will soon be just another hurdle to overcome, because exploration is all about confronting the unknown, preparing for the worst, and turning the impossible into the ordinary. The moon glows red, the sky fades into darkness, and temperatures plunge. Could lunar eclipses pose a new challenge?